Um, Virtual reality architecture. Here you can see architectural diagram of virtual reality. Um, the use of computer modeling and simulation that enables a person to interact with an artificial three-dimensional 3D visual or other uh, sensory environment. VR applications immerse the user in a computer generated environment that simulates reality through the use of interactive devices which send and receive information and are worn as goggles, headsets, gloves, or bodysuits. In a typical VR format, a user wearing a helmet with a stereoscopic screen views animated images of a simulated environment. The illusion of being there, uh, telepresence, is affected by motion sensors that pick up the user's movements and adjust the view on the screen accordingly, usually in real time, the instant the user's environment, the instant the user's movements take place. Thus, a user can tour a simulated suite of rooms, experiencing changing viewpoints and perspectives that are convincingly related to his own head turnings and steps. Wearing data gloves equipped with force feedback devices that provide the sensation of touch, the user can even pick up and manipulate objects that he sees in the virtual environment. Now we are focusing on input processor. The input processors of a VR program control the devices used to input information to the computer. There are a wide variety of possible input devices: keyboard, mouse, trackball, joystick, 3D and 6D position trackers, glove, band, head tracker, bodysuit, etc. A networked VR system would add inputs received from net. A voice recognition system is also a good augmentation for VR, especially if the user's hands are being used for other tasks. Generally, the input processing of a VR system is kept simple. The object is to get the coordinate data to the rest of the system with minimal lag time. Some position sensor systems add some filtering and data smoothing processing. Some glove systems add gesture recognition. This processing step examines the glove inputs and determines when a specific gesture has been made. Thus, it can provide a higher level of input to the simulation. Here you can see virtual reality system hardware. The major components of hardware are VR engine or computer system, input devices, and output devices. Uh, uh, the input devices are the means by which the user interacts with the virtual world. They send signals to the system about the action of the user, so as to provide appropriate reactions back to the user through the output devices in real time. They can be classified into tracking device, point input device, biocontrollers, and voice device. Tracking devices, sometimes referred to as position sensors, are used in tracking the position of the user, and they include electromagnetic, ultrasonic, optical, mechanical, and gyroscopic sensors, data gloves, neural and bio or muscular controllers. Example of point input devices include 6DOF mouse and force or spaceball. Their technology is an adaptation of the normal mouse with extended functions and capability for 3D. Voice communication is a common way of interaction among humans, so it feels natural to appropriate it into VR system. Voice recognition or processing software can be used in accomplishing this. Here we are mainly considering input devices and input processor, but I will provide some information on computer, VR engine, and output devices. Here you can see a VR engine. In VR system, the VR engine or computer system has to be selected according to requirement of the application. Graphics, display, and image generation are some of the most important factors and time-consuming tasks in a VR system. The choice of VE engine depends on the application field, user, I/O devices, a level of immersion, and graphic output required, since it is responsible for calculating and generating graphical models, object rendering, lighting, mapping, texturing, simulation, and display in real time. The computer also handles the interaction with users and serves as an interface with I/O devices. The major factor to consider when selecting VR engine is the processing power of the computer, and the computer processing power is the amount of sensors, graphical, sound, haptic, etc., that can be rendered in a particular time frame as pointed. The VR engine is required to recalculate the virtual environment approximately every 33 milliseconds and produce real-time simulation more than 24 FPS. Furthermore, the associated graphic engine should be capable of producing stereoscopic vision. The VR engine could be a standard PC with more processing power and a powerful graphic accelerator, or distributed computer systems interconnected through high-speed communication network. So additionally, I'm going to describe output devices here also as an additional information. The output devices get feedback from VR engine and pass it to the users through the corresponding output devices to simulate the sensors. The possible classification of output devices based on the sensors are graphics, visual, audio, oral, haptic, contact or force, smell and taste. Of these, the first three are frequently used in VR systems, while smell and taste are still uncommon. Two possible common options for the graphics are stereo display monitor and HMD, which provide a higher level of immersion. In the HMD, the two independent views produced are interpreted by the brain to provide 3D view of the virtual world. Audio or sound is an important channel in VR. Its importance is only surpassed by that of visual. 3D sound can be used in producing different sounds from different locations to make VR application more realistic. Haptic is used to allow the user feel virtual objects. This can be achieved through electronic signals or mechanical devices. Here we are mainly focusing on input devices related to and basically we are considering input processor here. Here you can see processors on bindings in Unity. An input processor takes a value and return a processed result for it. The received value and result value must be of same type. The processor stick dead zone stick dead zone processor scales the value of vector 2 control such as a stick so that any input vector with the magnitude smaller than min results in 0 0 and any input vector with the magnitude greater than max is normalized to length 1. Many controls don't have a precise resting point, that is they don't always report exactly 0 when the control is in the center. Using min value on a dead zone processor avoid unintentional input from such controls. Also some controls don't consistently report their maximum values when moving the axis all the way. Using the max value on a dead zone processor ensures that you always get the maximum value in such cases. The operand type of dead zone is vector 2 and parameters are float max and float min. The processor scale vector 2, the name scale vector 2 multiplies all input values by x along x-axis and by y along y-axis. An operand type vector 2 and parameters float x and float y. We can consider this as example 2. If you create your bindings in code, you can add processors like this. Processor invert vector 2 inverts the values from control, that is multiplies the values by -1, inverts x axis of the vector if invert x is true, and y axis if invert y is true. Here invert x is false, and a parameter operand type is vector 2, and parameters are bool invert x and bool invert y. As an example 3, we can consider this code segment. You can also write custom processes here, writing custom processes in Unity. Custom processes are available in the UI and code in the same way as the built-in processes. Add the class derived from input processor t value and implements the process method. And if you want to tell the input system about your processor, call input system.register processor in your initialization code, or you can do locally within the processor class derived from input processor also. The class input processor t value, a processor that conditions transforms input values. The type parameter t value, the type of value to be processed, only input controls that use the same value type will be compatible with the processor. This class is in namespace unity dot input system. As an example 4, we can consider this one. Tell the input system about your processor in Unity. You can call input system dot register processor in your initialization code. Input system, the class input system, this is the central hub for the input system. The register processor t string, here register and input processor t value with the system. Here the parameter is string, name to use for the processor. If null or empty, then the name will be taken from the short name of t here. If it ends in the processor, that suffix will be clipped from the name. Names are case sensitive. As an exception example, we can consider this argument exception. Don't know how to convert primitive value to object, parameter type, parameter name type. Unity engine dot input system dot utilities dot primitive value dot convert to system dot type code type, etc. And here you can see at library package cache com.unity.input stream at 1.0.1 0 input system utilities primitive values.cs, etc. Now we are focusing on simulation processor. The core of a VR program is the simulation system. This is the process that knows about the objects and the various inputs. It handles the interactions, scripted object actions, simulations of physical laws, real or imaginary, and determines the world status. This simulation is basically a discrete process that is iterated once for each time step or frame. A network VR application may have multiple simulations running on different machines, each with a different time step. Coordination of these can be a complex task. Here you can see a detailed game engine architecture. Currently, no specific standard architecture has been developed in the literature. This figure shows a detailed game engine architecture. We consider only some features that are most likely important. Manager components are essential to all games. A physical manager is important for games dependent on physical interactions. For example, car racing needs physical laws, but this is not so important for card matching game. However, input manager and GUI system are important even for a simple game to process user input. The scene manager is required to organize and control the scene content and monitor game's logic. The game loop, this is the scene manager here. The scene manager is required to organize and control the scene content and monitor the game logic. As I mentioned before, game loop. The game loop is used to control an infinite loop that keeps the game running over and over again. The network component is responsible for managing user connections and game data access. The AI system is a special module designed and written by software engineers with specialized knowledge, and the additional manager components which depend on programmer and coding approaches like game states, rule engine, and speech recognizer may be needed at specific times. Designing a game engine solution to fit all game purposes is a challenging problem for an engine developer. There's a need to define key design principles and provide advice to create successful engine. We can consider 5 principles: modularity, usability, library resources, efficiency, rendering effects, and picture quality. Here you can see input. Input is connected to the game engine. User input is passed from input to game engine, and framework is here, and you can see the game engine here. It has input manager, GUI system, different manager and collision detections, scene manager, game loop, network, and AI system. Here you can see input manager and GUI system, and here you can see physics manager, and here you can see collision detection, and error manager, event manager, resource manager, and entity manager. Graphical rendering, tactical rendering, and audio rendering is inside scene manager. Here you can see game loop, network, and AI system. Here you can see output. As an example, we can consider Unity. Unity is a cross-platform game engine developed by Unity Technologies, first announced and released in June 2005 at Apple Incorporation's Worldwide Developers Conference as a Mac OS exclusive game engine. The engine has since been gradually extended to support a variety of desktop, mobile, console, and virtual reality platforms. It is particularly popular for iOS and Android mobile game development and used for games such as Pokemon Go, Monument Valley, Call of Duty Mobile, Beat Saber, and Cuphead. It is considered easy to use for beginner developers and is popular for indie game development. As an example too, we can consider Unreal Engine. Unreal Engine UE is a game engine developed by Epic Games, first showcased in the 1998 first-person shooter game Unreal. Initially developed for PC first-person shooters, it has since been used in a variety of genres of three-dimensional 3D games and has seen adoption by other industries, most notably the film and television industry. Written in C++, the Unreal Engine features a high degree of portability, supporting a wide range of desktop, mobile, console, and virtual reality platforms. As an example 3, we can consider this one, developing simple game with Unity and C#. If you look in the here you can note the public variable. If you look in the editor, you can see that this public variable appears with an option to override the default values at runtime. This is pretty cool, and you can change defaults in the GUI for primitive types, and you can also expose public variables, not properties though, of many different object types. If I drag and drop this code into another game object, a completely separate instance of that code components get instantiated. This is a basic example, and it can be made more efficient by, say, adding a rig body component to this object. Here you can see these variables, these values will appear in the editor, full properties will not. And here called on startup of game object, it's assigned to this void start, and find the game object that has a tag, that has the text tag player assigned to it. This is startup code, shouldn't query the player object every frame, store a reference, store a ref to it. Here not a player, if not a player, then we can debug.log error here, and else grab a reference to its transform for use later, saves on manage code to native code calls, grab a reference to our transform for use later, called every frame, the frame rate varies every second, the void update. Here we are setting how fast should move towards the player per second. In Unity, 1 unit is a meter. The time dot delta time gives the amount of time since the last frame. If you are running 60 FPS frames per second, this is 1 divided by 60 equals 0.0167. So W divided by speed is 2, and frame rate is 60 FPS. Frame rate always varies per second. So we have a movement amount of 2 multiplied by 0.0167 equal 0.033 units per frame. This is 2 units. Update the position, move towards the player's position by move amount. Here you can see the mono behavior class. Mono behavior is the base class from which every unit script derives. When you use C#, you must explicitly derive from mono behavior. As an example 4, we can consider the box collider in Unity. The box collider is a basic cuboid shaped collision primitive. Box colliders are rectangular cuboids and are useful for items such as crates or chests. However, you can use a thin box as a floor, wall or ramp. The box collider is also a useful element in a compound collider. Here you can see some properties. Is trigger. If enabled, this collider is used for triggering events and is ignored by physics engine. Material, reference to the physical material that determines how the collider interacts with others. Center, the position of the collider in the object's local space, and size of the collider in the X, Y, Z directions. As an example 5, we can consider this code segment. This is the game object that is colliding with your game object. Access this to check properties of the colliding game object. For example, game objects name and and tag. The collision describes a collision. Collision information is passed to collider dot on collision enter collider dot collider dot on collision stay and collider dot on collision exit events. Property game object. The game object whose collider you are colliding with. See, this is read only. This collision is implemented in unity.physics module. Here you can see detect collisions between game objects with colliders attached. This is check for a match with the specific name on any game object that collides with your game object. And if the game object's name matches the one you suggest, the output this message in the console. Check for a match with the specific tag on any game object that collides with your game object. If the game object has the same tag specified, output this message in the console. We can consider this as an exception example. Unassigned reference exception, unassigned exception in Unity. Basic solution for these are in Unity. Solution 1, number of rows found exception. Make sure there are several drugs objects. It may be the multiple game objects in the scene mount the same script, but some components forget to assign values. Now we are focusing on rendering processor. The rendering process of a VR program are the rendering processes of a VR program are those that create the sensations that are output to the user. A network VR program would also output data to other network processes. There would be separate rendering processes for visual, auditory, haptic, touch, force, and other sensory systems. Each renderer would take a description of the world state from the simulation process or derived it directly from the world database for each time step. As an example, we can consider the class renderer in Unity. General functionality for all renderers. A renderer is what makes an object appear on the screen. Use this class to access the renderer of any object, mesh, or particle system. Renderers can be disabled to make object invisible, and the materials can be accessed and modified through them. This is implemented in Unity Engine.core module. As an example 2, we can consider single pass stereo rendering. Here you can see left eye and right eye images packed together. To enable this feature, open the player settings menu, edit, project settings, then select player category, then navigate to the XR settings panel, then ensure the virtual reality supported checkbox is ticked, and select the single pass option from the stereo rendering method drop down. Single pass stereo rendering is a feature for PC and PlayStation 4 based VR applications. It renders both left and right eye images at the same time into one packed renderer texture that is twice the width of the single eye texture. Unity renders the scene twice using 2 draw calls for each game object that has renderer component. However, it only iterates through the scene graph once when rendering for both left and right eyes. During single pass stereo rendering, both eyes share the work required by culling and shadow computation. There are also fewer graphics command state change switches because GPU renders each game object in a ping-pong fashion, alternates rendering of objects between eyes. This code examples demonstrate what you need to change in your fragment shader code to support single pass stereo rendering. Post-processing effect rendered with BLIT method do not automatically reference the correct part of packed stereo renderer textures. By default, they refer to the entire texture. This incorrectly scratches the post-rendering effect across both eyes. For single pass stereo rendering using BLIT, texture samplers in shaders have an additional auto-calculated variable which refers to the correct half of the packed stereo renderer texture depending on eye being drawn. The variable contains scale and offset values that allow you to transform your target coordinates to the correct location. To access this variable, declare a half for in your shader with the same name as your sampler and add suffix st variable to scale and offset, and use Unity stereo screen space UV adjust UV scale and offset. This method compiles to nothing in non-single pass stereo builds, meaning that shaders modified to support this mod are still compatible with non-single pass stereo builds. Here you can see property Unity stereo screen space UV adjust UV SB. If Unity single pass stereo is defined, this returns the result of applying the scale and bias in the SB to the texture coordinate in UV. Otherwise, it returns the texture coordinate unmodified use this to apply a per eye scale and bias only when a single pass stereo rendering mode. As an error example, we can consider this. The left eye is rendering incorrect light values, etc. in complex scenes involving multiple shaders. This is the problem occur. Error happened here. In environment Unity 5.0.0 P2, mobile SDK 0.4.3.1, Exynos Gear VR Android 5.0.1 Lollipop, Android ETC2, OpenGL ES 3.0 forced using default mobile SDK project settings. Now we are focusing on world database. The storage of information on objects and the world is a major part of the design of a VR application. The primary thing that are stored in the world database or world description files are the objects that inhabit the world, script that describe actions of those objects or the user, things that happen to the user, lighting, program controls, and hardware device support. As an example, we can consider this function set config cfg underscore asterisk can be used to swap fast between function set config cfg underscore asterisk can be used to swap fast between different scenes. The cfg underscore asterisk objects contain start positions, scene database files, world description files, fake object recognizer configs. This command will also start the required TMUX panels modules after writing to the parameter files. Caution, this will overwrite your current parameter files, so save them better before using this function. This in the package ASR underscore resources underscore for underscore active underscore scene underscore recognition. This package is the main entry point for active scene recognition, ASR. It contains helpers and resources, including the launch files to start ASR in simulation or on a real mobile robot. As an example too, we can consider XARM underscore gazebo package XARM underscore gazebo. The gazebo world description files and simulation launch files. User can add or build their own models in the simulation world file repository. So this is in the repository XARM underscore ROS. This repository contains the 3D model of XARM and demo XARM and demo packages for ROS development and simulations. Developing and testing environment Ubuntu 16.04 plus ROS Kinetic came. As an example, we can consider this world description file XARM underscore ROS / XARM underscore gazebo / worlds / XARM underscore example2 underscore table dot world in repository. This is in repository https :// github.com / xarm developer / XARM underscore ros.git. Here we can see the SD format here, simulation description format, sometimes abbreviated as SDF, is an XML format that describes objects, and environments for robot simulation, visualization, and control, originally developed as part of the gazebo robot simulator. SD format was designed with scientific robot applications in mind. Over the years, SD format has become a stable, robust, and extensible format capable of describing all aspects of robots, static and dynamic objects, lighting, terrain, and even physics. As an example 4, we can consider this file robot, the world description file xarm _ros xarm _gazebo /worlds /book /model.sdf in repository https://github.com /x arm -developer /exam _ros.git. Here you can see the SD format, simulation description format, sometimes abbreviated as SDF, is an XML format that describes objects and environments for robot simulators, visualization, and control. As an example 5, we can consider this file in the world description file in this world description file in this is in xrm _ros /xrm _gazebo /worlds /book in book directory. The name is model.config. This is in the repository https://github.com /xarm -developer /exam _ros.git. As an exception example, we can consider this case not zero. After calling this service, that ROS service, please check the error status again, and in xrm /xrm _status, if it becomes 0, the cleaning is successful. Otherwise, it means the error exception is not properly solved. If cleaning error is successful, remember to set the robot state to 0 to make ready to move again. Here, in not 0 case, it means the error or exception is not properly solved. The command for this is $ROS service call /xrm /move it _clear _error in repository. This package is in repository xrm. As an error example, we can consider one. This occur if any error occurs, one will be returned in the command $s ROS param set /xrm /wait _for _finish true designed repository xrm. This is end of my presentation. Thank you very much for watching it.